In the field of science, enormous mysteries pertaining to what existed prior to the gigantic explosion have sparked mixed conversations and fascinated characters for quite some time. This enormous question tests more than just our ability to decode the universe. It poses a challenge to the actual boundaries beyond which human knowledge extends. Imagine yourself at the brink of existence, looking into the colossal, observing and pondering the contents that existed before our universe was imagined. The Big Bang, which established the beginning of all things, including time and space, raises the question, was there a second earlier? Previously, could there have been a state of nothingness, a state of calm before the cosmic gathering started? If this is accurate, or perhaps there was something far more frightening that existed before the beginning of time. As we jump further into this question, science takes us on a journey past the universe's beginning point into thoughts that challenge our consciousness. Physicist Brian Cox, well known for his examination of the wonder of the universe, suggests that it's possible something surprising existed prior to the massive explosion. He directs us to reconsider our perception of the world and existence. In this investigation, we dissect the science, the speculation, and the amazing insider information that could figure out what happened before everything else. We will investigate ideas like self-importance in growth, quantum alterations, dark energy, and multiverses as well. The answers we've revealed might just paralyze you, yet they could likewise open new understandings of our position. Prepare to plunge into the depths of the universe, into a world beyond imagination and science, in the midst of the obscure, around the shadows, leaving scientists floored and sometimes even upset. We ought to investigate the pre-Big Bang and why these theories challenge all that we thought we knew. To appreciate what may have existed before the Big Bang, we must first painstakingly analyze what the Big Bang was. According to scientists, the Big Bang defines the point in time when the universe, extremely dense and hot, rapidly expanded to cause the growth of all matter, energy, and boundless forces. When we look toward the night sky, it reveals evidence of this hot beginning, with galaxies spreading out this way and that from an early stage point. But why exactly did this happen? Furthermore, was there a period prior to this blazingly fast start? As indicated by the theory of enormous expansion, before there was without a doubt no void or peaceful expansion. A vast universe existed before the Big Bang, a state that was cold, vacant, and loose, essentially like an immense vacuum. Nevertheless, this vacuum was not entirely unfilled. It contained a gigantic amount of vitality that fueled this rapid extension of space itself. Called inflation, this occurred so quickly that it basically established the groundwork for all that would continue. In a fraction of a second, space extended at unfathomable rates until the extension slowed down, and the energy transformed into matter-like atoms and the forces that we consider to be the Big Bang. But what was the nature of this energy? Why did the universe grow suddenly? And why did it stop? Specialists believe that this incredible expansion brought about each patch of the universe experiencing its own Big Bang. Imagine a fabric that extends indefinitely with minuscule air pockets, forming here and there, each air pocket representing a universe, which includes our own. This idea, called the multiverse with inflation, suggests that there are possibly limitless Big Bangs and an infinite number of universes. Our own is just one of many. This enormous, perplexing reality impedes our comprehension of the universe, as a whole leaving us with the question, what else is out there? The idea of nothingness before the Big Bang is speculative, not real at any rate, as per our current understanding. Regardless of whether you eliminate all energy, particles, and radiation from the universe, it still wouldn't be genuine darkness. Quantum fields, dark energy, and other forces weave an inevitable embroidered tapestry of something, even in its most empty building. Regardless of whether we can picture removing everything, these forces create a vacuum that the universe would still generate new kinds of energy. This reality is bewildering to specialists, as it implies that real nothingness might be impossible. within our infinite comprehension. Space itself has properties, rules, and constants that stop it from being completely empty. Imagine creating a region with literally no particles, radiation, or energy except quantum fields and important constants. These would not change, implying that this absence has properties including, for instance, a phenomenon known as zero-point energy, which is the lowest possible energy condition of quantum fields. In this state, particles can still momentarily appear and evaporate, making a creepy movement resonance even in what ought to be empty space. This challenges our idea of a real void and suggests that, yes, even before the Big Bang, there was something that scientists are just beginning to comprehend. One of the most astounding theories in current cosmology is the chance of eternal expansion. If inflation were to result in our universe, it's possible it could continue indefinitely. Brian Cox describes astonishingly high levels of inflation in a multiverse where universes are infinitely created and continue expanding. Consider every Big Bang to be a flash that illuminates another universe, while inflation continues in different areas, transforming numerous other universes. This cycle could theoretically continue indefinitely. The concept of vast universes leads to an enchanting concept of a fractal universe, where each new universe might actually produce its very own Big Bang. Each universe is its own entity, an independent domain without the others, because of the rapid expansion of space. For researchers, this hypothesis is both exhilarating and harrowing, as it suggests a never-ending multiverse with no definitive beginning or end. Imagine our universe being just one bit in a giant cosmic structure, forever expanding and constantly making new universes. What if the actual problem is that there is no before or after, but rather a timeless pattern of universes forming and decaying? When we take into consideration quantum field theory, according to this theory, the universe is not just an assortment of matter floating in space. Instead, it's a complex energy network of fields that fill the universe, connecting to make everything we see. These fields are similar to unnoticeable seas, with waves or particles acting as disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and disappear in these fields momentarily, acquiring energy before it is returned. This phenomenon results in virtual particles, substances that first appear and then vanish, leaving only a hazy recollection of their presence. The concept of virtual particles challenges the idea of a real void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you have total nothingness? Quantum field theory says that fields would remain active, sometimes creating transient particles. This constant movement in the absence of anything suggests that the universe doesn't acknowledge our notion of emptiness. The fields and forces endure, filling the universe with hidden energy that prevents absolute nothingness. This knowledge brings about an intriguing question. If fields produce particles and particles make matter, could the universe itself have emerged from this void filled with quantum fields? Dark energy is an unidentified force that drives our universe's rapid expansion. But did dark energy exist prior to the Big Bang? Certain perspectives suggest that the fact that dark energy exists today is a leftover of an energy field from before our universe's development. Dark energy's properties seem to suggest a colossal hidden force that may have been present prior to the Big Bang. According to some hypotheses, dark energy in a much stronger state could have controlled the inflationary phase that resulted in rapid expansion. Dark energy's presence suggests that, regardless of whether our universe was devoid of all matter and heat, this force would persist to expand the fabric of space-time. This thought leads to an upsetting question. If dark energy existed prior to the Big Bang, could it have formed the circumstances that led to the birth of our universe? Could dark energy be the silent architect of inflation or even the true beginning of our universe? As we explore this possibility, we face the potential of dark energy not just as a force that has shaped the universe, but as a key that could unlock the secrets of the multiverse itself. Another theory that provides a replacement for the Big Bang. As the ultimate beginning is cyclic cosmology, the idea that the universe goes through innumerable cycles of birth, death, and rebirth. In this model, the Big Bang is not a one-time event, but rather a component of an eternal rhythm in which universes expand, then collapse, and regenerate in another cycle. This theory suggests that the universe we live in may have been reborn from the remnants of a past universe. The process of contraction and expansion in a cyclic pattern would mean that there was never a real start, but rather an eternal series of universes that are emerging, expanding, and renewing themselves over and over again. Cyclic cosmology raises significant questions concerning the notion that time itself might be cyclical rather than linear. If this theory is correct, it could mean that what existed before the Big Bang was just another version of the one universe that collapsed, only to rise again, giving birth to our current universe. Researchers say that this theory has a lot to answer for the question of ultimate origins, proposing that there is no true beginning. The universe has always existed in some form, transcending our early concepts of time and existence. Gravitational waves are another intriguing idea that could hold clues to what existed before the Big Bang. Gravitational waves are ripples in space-time caused by massive cosmic events, and scientists believe early-stage waves, if ever detected, could reveal insights into the universe's earliest moments. These waves could serve as the echoes of what came before the Big Bang. Should they be identified, they might provide proof of the universe's previous states. The potential discovery of early-stage gravitational waves is one of the most exciting possibilities in contemporary cosmology, as it may not only reveal the truth about the Big Bang, but also offer a glimpse into the cosmic state prior to the birth of our universe. This theory presents a tempting possibility: detecting waves of gravitation that could act as fingerprints of a pre-Big Bang universe. As we continue to explore what could have existed before the Big Bang, we investigate ideas that push the boundaries of our understanding, putting us in danger of challenging our most fundamental assumptions about space, time, and self-existence. Among the most amazing concepts originate from the realm of quantum gravity, a field that seeks to meld general relativity and quantum mechanics. This merger could potentially reveal a unified theory of everything and may provide an understanding of what existed before the Big Bang. According to quantum gravity, time and space are not smooth, continuous entities as we experience them, but instead are discrete, granular structures. According to this theory, the fabric of space-time itself could have originated as a result of a microscopic Planck-scale structure with tiny quantum changes that shape the universe in ways that we do not yet comprehend. What we perceive from this perspective as the smooth space-time continuum, it's possible that time only emerged from these fluctuating quantum fields. Thus, the before the Big Bang could be described by a completely different idea of reality, one where space and time themselves lacked completeness. Another possibility is that the universe is part of a vast cosmic landscape of possible universes, each with different physical laws and constants. This theory, which is based on the string landscape, arises from string theory, which suggests that all fundamental particles are actually tiny, vibrating strings. In this framework, there are many possible configurations of these strings, each corresponding to a different set of physical laws. The string landscape may suggest that our universe is just one of many, each emerging from its own distinct Big Bang-like event. The existence of such a landscape also brings forth the notion that other universes might have different strengths, dimensions of gravity, or even various kinds of matter. In this view, our universe might not be unique, but rather part of a multiverse, a collection of universes, each evolving independently. The multiverse theory offers a hypothetical, yet intriguing response to the question of the universe prior to the Big Bang. Another universe, arranged in a different way, potentially leading to infinite cycles of creation and annihilation without a definitive origin. In addition to these, some theoretical models of the cosmos, physicists have also considered the role and influence of black holes on the nature of the universe. A growing hypothesis is that our universe may be the result of the formation of a black hole in another universe. In this scenario, the singularity at the center of a black hole might be a way to get to another universe. After the Big Bang was the moment when a similar black hole produced our cosmos. This hypothesis is bolstered by the fact that, as per general relativity, the singularity at the center of a black hole is a point where space and time curve infinitely, creating a region where the known laws of physics break down. It's possible that the extreme conditions inside black holes could lead to the creation of new universes, which may suggest that what we consider the Big Bang was merely the birth of our universe from the singularity of an ancient black hole. Exploring. These ideas requires an in-depth investigation of the very nature of time itself. Some cosmologists speculate that time, as we are aware of it, might not have meant anything prior to the Big Bang, assuming that there might not have been a before, in any standard sense. This point of view suggests that time itself might have emerged from a quantum fluctuation, or from an initial state in which the typical differences between the past, present, and future did not exist. If this were the case, it could lead us to reconsider the idea of causality, which relies on the assumption that events take place in a straight line. If time did not exist in the way we experience it, then the question of what preceded the Big Bang becomes nonsensical, as there would be no temporal framework to support it. Further complicating the picture are theories of cyclic time. As mentioned previously, cyclic cosmology posits that the universe goes through endless cycles of birth, development, and eventual demise. In this model, the Big Bang could symbolize merely the most recent swing in an eternal series of universe cycles. These cycles might not be identical, but could evolve in different directions, each with unique physical properties. The cycle of the universe, according to this theory, would be an ongoing process without a true beginning or end, rendering the question posed prior to the Big Bang, in the conventional sense, meaningless. The idea that time itself might be cyclical suggests that every Big Bang could be followed by a contraction and another big crunch, with the universe reinitiating itself in an endless loop. Another means of looking into the potential of the cosmos is its nature, a primordial soup of particles and fields that existed prior to the establishment of stars and galaxies. This concept suggests that before the universe began its rapid expansion, it was stuffed to the brim with a dense and hot mixture of elementary particles, including quarks, leptons, and bosons, all in a state of extreme energy. These particles would have been interacting at extremely high density and temperatures, laying the groundwork for the formation of matter and energy as the universe cooled. Some versions of this theory suggest that this primordial soup existed in a quantum foam, where particles kept appearing and vanishing due to the uncertainty principle of quantum mechanics. The properties of this soup could potentially offer insights into the universe's beginnings and, by extension, what, in the end, preceded the Big Bang itself. What existed before the Big Bang remains one of the most profound mysteries in science. As our understanding of quantum mechanics, cosmology, and fundamental physics deepens, new theories will continue to emerge, offering increasingly complex and sometimes paradoxical explanations for the origins of our universe. We might never fully comprehend what came before the Big Bang. The search for this information will continue to stretch the limits of human curiosity, driving us to explore the unknown frontiers of existence.